Morning, guys. My name's Mark Lindsay, and
Mark Lindsay?
yeah,
Oh, Paul Revere and the Raiders.
he spelled his different. Yeah. Get that a few times. We're about the Turbolex blowers. I don't know how much you guys have looked at them. This animation probably will answer a lot of questions right off the bat on how they work. The uniqueness of our blowers is that we can vary the output and maintain efficiency. Most blowers, either you would restrict the output with a valve where you're wasting energy that's deadheaded, or you use variable frequency to drive to reduce the speed, and you lose efficiency when you reduce the speed of the motor. Our motor always stays at the nameplate RPM. We vary our airflow by controlling the output through the variable diffusers. They'll be coming up here in a second. These are variable diffusers around the outside. As they open, they'll allow more air to escape into the platen, which goes to the exhaust. When you reduce this airflow, the airflow out, you still can develop more head pressure than you would like. To control or reduce the amount of the air coming in, we have inlet guide vanes, which are here. Those are what give you the efficiency. The VDs, the variable diffusers around the outside, control the output, and based on their position and some other parameters, these inlet guide vanes will control the amount of air coming in to get a maximum efficiency.
Is that all based on static pressure? How those open and close?
No, the variable diffusers, which control your output, will base their percentage of output on what you ask of it. When you're operating this, there's a scale from 45 to 100%, and by adjusting their opening, you control what you want out. Now, whether you're running in flow control or pressure control, that's up to you, and that's going to be determined by your SCADA. Your SCADA system is going to send us a more or less air, and we will react accordingly to that. Does that answer your question? As I said, these open based on a percentage. If they're open, say at 75%, and you set them at that in the morning, like this morning, it's 70 degrees out, and you need X amount of air, you set those at 75%. You come back at 3 in the afternoon, and it's now 85 degrees outside. It's going to take more air in to give you that same air out. Air is denser when it's cold. So based on where the diffusers are set, the air temperature, and the pressure of the system, there is a subroutine in the program, the PLC, that calculates where to open the IGVs to. And that subroutine will maintain the maximum efficiency. It's a turbine blower, as you can see. These inlet guide vanes also serve the function as they close, they pre-rotate the air.
So that's all going to be programmed in the SCADA system.
As far as
Opening of those diffusers.
no, that's all programmed at the blower itself. That's part of our subroutine.
Okay.
So that'll do that if you're running in local mode or remote, no matter what. There's a program that they have, and then when we get the blower itself in, which we get the blowers from Germany, when we get that, they've been pre-ran and they have numbers from when they're running. Those numbers get punched into the program. So of your 4 blowers here, you could have them all set at the same amount of output, and they might have differences in where the input gains would go to. The blowers will run, as I said, from 45 to 100%. 45 is as low as we can go. If you try to go lower than that, the blower can surge, and we'll talk more about surging a little bit later. The way your system will work is one blower will start, and it will go all the way up to 100%. If it reaches 100% and it still hasn't met what the SCADA system is asking for air, it will reduce that blower back down to 45%. It will start a second blower, and then it will bring both of those blowers up in parallel until it reaches the airflow that it wants. If it still hasn't reached that, it will then start back both those 2 blowers down to 45%. Start a third and bring the 3 up at the same time, if that was needed. I don't know what your system requirements are. I don't think that you'll be running more than 2 at a time, but that, I don't know. We have a bowl gear. This is connected to the motor. The motor turns the bowl gear. You'll notice from the picture when it comes back right now, the gear on it is large, and the shaft on the top has a smaller gear. We're speeding up this turbine. It also reverses the rotation of it. Just a little background on Turblex. Formed in 1989, Guy Mace, president. This tenure will be over in October. You see on the bottom, this Turblex was purchased by Siemens in November of '06. As of the 1st of this year, it became official part of Siemens. That's pretty much the only thing that's changed so far. The turbine, the blower part itself is bought from Germany. It's bought from HV Turbo of Denmark. We get that in, we build the skid, put on the motor, all the controls. We do keep pretty much all parts in stock. Can be shipped within 24 hours. Located in Springfield, Missouri. And we do have support 24/7. Those 2 numbers should get you to somebody, or a number to get a hold of somebody if you have an emergency. Those numbers should be in, I don't know if they'll be in your packets, but they will be in the O&M manual. I don't know who'll end up with the O&M manual, but pretty much any questions you have, I'd suggest looking through it first. It has just about every piece of information that you need to know about the blower. Blower number, it's definitely on the blower itself. You call in for parts or for help, I would have your blower model number and the serial number of the blower. Serial numbers are located on, and the part number are on the local control panel. So if you're down at the blower working, you can grab those numbers off of it. Find your sheet here, just make sure I get this right. Your blower number is actually a KA44SV. KA is compressor air, German. 44 is the size. 44 is about the middle of the sizes that we have. S means that it has the variable diffusers to control the output. The V, yours also has a V, and that means it has the inlet guide vanes for the efficiency. There's a dash, and then the GL, yours is a GL 225. That is the gearbox size. This is a basic drawing of a system. You have a local control panel. This is where all your relays, your PLC, all tie into where you'll actually can control it if you're controlling the blower from locally. You have the motor, the blower itself, the big round part here, and the gearbox, discharge cone. We have a blow-off valve, a blow-off silencer. We also have a check valve and a discharge valve. When you are ready to start this blower, or when it is sitting idle, there are certain conditions that it will want to be in. And if you go to press the start button and these conditions aren't met, it's not going to let you start. And we'll tell you when you try to start it what it is not happy with. One of the conditions is that the blow-off valve has to be open. When we start the blower, we don't want to start it into a completely closed system. We have to have a place for the air to go. So we will have the blow-off valve open. The air pressure you create will go through that valve into the atmosphere. At the time that you start it, the discharge valve will be closed. We have the inlet guide vanes and the diffuser vanes will both need to be at their minimum position. So if there's a problem with those and they're stuck somewhere, you're not going to be allowed to start.
Is that done through SCADA, or you go to manual?
That's all, this is all in our local control panel.
So you don't have to open the valve, close this one?
No, it'll do this for you.
That's all
And it-
It's all automated,
Yeah.
blow-off valve.
Yep. And everything I'm telling you right now, this is gonna do, the blower's gonna do this itself. Really, the only thing we're gonna get from SCADA is more or less air. That's the only thing we're gonna get from there. And as I said, you can run these locally. If your SCADA's down, you can go down to the control panel and tell it you want more air, you want less air, shut it off. Everything can be done locally, but I am not sure what signals will be going to SCADA from us. There may be, I don't believe there are very many. I believe most of them are getting outside of our system. When you press the start button, the system's going to go through a series of steps. And the first one is going to start an auxiliary oil pump. This is for pre-lubrication of the bearings in the blower. The auxiliary oil pump will run for 120 seconds, 2 minutes, at which time it'll energize the contacts for the main motor. The main motor will start. Once the main motor has achieved full speed, the discharge valve is going to start opening and letting air into the system. While the discharge valve is opening, the inlet guide vanes are going to open to maximum. And they go to maximum so that the system can get all the air that it needs until it is stabilized. Once the discharge valve is fully opened and the inlet guide vanes are fully open as well, the blow-off valve is gonna start to close. And it will close, probably it will seem relatively slow. It's timed. It's gonna close for 2 seconds, pause for 5, close for 2. We close it slowly so that we don't surge the system again. We don't want to surge. Surging is a bad thing, and it's something that we have safeties in to try to prevent. It's not always preventable. It won't typically wreck anything, but it's not good for it either. When the blower surges, the impeller will move back and forth, and there's some weight to that. If it surges, you'll know it. You'll definitely see the whole skid move, you'll hear it. As I said, there are things that we do to try to prevent that. One of them is how we start up the system. When we shut it down, we'll go through a sequence again. Shutting down, we will open the blow-off valve first, so we have a place for the air to go, and then we will start. It'll bring the diffuser vanes and the inlet guide vanes both to minimum, so you have a minimum airflow, and then it'll start closing the discharge valve to seal it off from the rest of the system. This is something you probably won't see unless you're around for a tear down. This is what the inlet portion of the blower looks like. Usually this is covered by the air filters, the air box. This particular blower shows the inlet and the impeller. This blower does not have the inlet guide vanes on it. The inlet guide vanes will be sitting directly in front of the impeller here, and would sit around it like this. We may have a better picture of that in a minute, I'm not sure. We have a manual inlet temperature gauge. This is for visual verification of the air coming in. The inlet air has to stay within a certain temperature parameter, and that's set up on the LCP. I'm not sure exactly what yours is